Long before humans existed, nature developed poisons for hunting, defense, or control. In this video, I'll introduce you to 7 poisonous animals that are now extinct. Some were gigantic, others tiny, but they all had one thing in common. They were toxic, effective, and deadly. Some of them you will definitely never forget. Palaeophis, the ancient sea snake. Imagine a sea snake up to 9 meters long, with a serpentine body gliding through tropical coastal waters. That was exactly what Palaeophis was, a prehistoric relative of modern sea snakes. This creature lived about 50 to 60 million years ago, shortly after the extinction of the dinosaurs. Fossil remains have been found in Europe, Africa, and North America. Its spine was especially flexible, a sign of its adaptation to aquatic life. Some species reached lengths of up to 10 meters, making them one of the largest known marine snakes. Even though no direct evidence of fangs has been preserved so far, there is much to suggest that Palaeophis was venomous, like its modern relatives, including hydrophytes. Their body shape, hunting method, and tooth structure strongly indicate a venomous biting technique, which they use to paralyze fish and smaller marine creatures. A single bite from this dangerous creature would have been more than enough to completely immobilize you, before you even realized what had happened. A silent huntress from the depths, giant scolopendrid, fossil myriapods with venomous claws. Today they are already frightening enough, but their ancestors were even more dangerous. Fossil giant scolopendrids, that is, prehistoric centipedes, reached lengths of over a meter and likely actively hunted smaller animals with their venomous claws. Modern scolopendrids possess so-called forcipules, modified legs that function as venomous appendages. They penetrate the prey and inject a fast-acting neurotoxin. This exact structure can also be detected in fossil species, especially in specimens from the Carboniferous period. The combination of high agility, armor, and venom made them perfect ambush predators on the forest floor of prehistoric times. The larger species were probably capable of taking down amphibians or even the young of other vertebrates. These animals impressively demonstrate that venom is not exclusive to snakes or spiders. Arthropods too mastered the art of chemical warfare hundreds of millions of years ago. Giant fossil isopods with venomous stingers. Today, isopods or woodlice are mostly known as harmless ground crawlers or deep-sea creatures. But in prehistoric times, there existed fossil species that were much larger and more dangerous. Some of these isopods reached lengths of 50 centimeters or more, comparable to modern giant isopods, but with different anatomical features. Particularly striking, evidence of a stinger-like segment at the rear end of the body, which in some interpretations is considered to be a venomous stinger. Whether this organ was used for defense or for hunting is unclear. However, comparisons with modern, mildly venomous crustaceans, such as certain mantis shrimps or marine isopods, suggest that their fossil ancestors also possessed toxic tools. Imagine an insect as large as a forearm, moving through the forest floor or coastal waters, silent, armored, and equipped with a venomous stinger. Not everything that looks like a beetle is harmless. Palaeophis, the oldest known scorpion. It was small, armored, and deadly. Palaeophis is the most ancient known scorpion in Earth's history. Over 420 million years ago, it lived in the wetlands of the Silurian period. And yes, it was almost certainly venomous. Fossil finds clearly show that Palaeophis already possessed the typical and distinctive scorpion body plan, grasping pincers, a segmented body, and a curved stinger. The proportions are almost exactly the same as those of modern scorpions, an astonishing and remarkable example of evolutionary consistency. Since all modern scorpions possess venom, some of which is extremely deadly to humans, It is extremely likely that Palaeophis also had such a venomous system. Its venom probably served to hunt small animals and to defend itself against predators. This scorpion is proof that the concept of small but deadly was already perfectly realized in the early stages of life on land. Anyone who thought that only dinosaurs were truly dangerous is gravely mistaken. Megarachne cervini, giant spider or mistake? When Megarachne cervini was discovered in 1980, there was a great deal of excitement. Initially, the animal was thought by scientists to be the largest spider of all time, with a body diameter of well over 30 centimeters in diameter. Later, it turned out to be a eurypterid, in other words, a sea scorpion. But the question of venom remains intriguing. Even as a sea scorpion, Megarachne was a potential user of venom, especially since it comes from a lineage in which toxic stinger structures were widespread. The original assumption that it was a spider was not unfounded. Its body structure, rounded with spider-like segments and leg attachments, strongly resembled modern tarantulas. And since almost all spiders are venomous, it was assumed here as well that it had venom, whether spider or scorpion. Megarachne was most certainly not an animal you'd want to get too close to. It stands as a symbol for the shadowy transitions between animal classes and for the mistaken belief that size means safety. Primeval jaw worms, anomalocaridids, and the venom hypothesis. The jaw worms of the Cambrian, known as anomalocaridids, are among the strangest creatures in Earth's history. Huge compound eyes, fin-like flaps, and a round pincer-like mouth. They were the dominant rulers of the early ancient seas, and perhaps venomous as well. Some theories, based on fossil imprints and the structure of their mouths, suggest that they used enzymes or toxins when biting to paralyze or dissolve their prey. It wouldn't have been a direct venomous sting, but rather a chemical attack that penetrated deep into the tissue. Their body shape and biomechanical design did not allow for powerful bites like those of sharks. So a chemical addition would make sense. Today, we know of many marine animals that inject enzymes for digestion. So why not these as well? If that's true, then the jaw worms would not only be the first active predators, but also the first toxic ones. There is a hypothesis that makes these ancient creatures even more unsettling. Paleothele moncuensis. This ancient spider was definitely venomous. Finally, here is an animal about which there is absolutely no doubt. Paleothele moncuensis is considered to be one of the oldest known true spiders. It lived over 300 million years ago and was already equipped with a fully functional venom gland system. In contrast to many earlier types of spiders, Paleothele shows a fully developed spinning apparatus, including chelicerae, venom fangs, and glands for secreting neurotoxins. Fossil evidence points to active hunting behavior and web building, just like their modern relatives. It was small, quick, and deadly to insects and other small animals. Its potent venom paralyzed its unfortunate prey within just a few seconds, allowing it to bite down with its powerful jaws before the victim could even react. This spider represents a fascinating group of animals that have been successfully using venom for hundreds of millions of years. And it clearly demonstrates that deadly power does not require great size, only the process of evolution.